How to code a star-filled skybox shader? Find out here. Sky, space and stars are the thing I find very fascinating, so today I will create a nice star-filled outer space skybox. Hello everyone and welcome back to the channel. My name is Digvijaysinh Gohil and in this video I will be writing a skybox shader that you are seeing here. So if it sounds interesting to you, stick around. For the tutorial, I will be using Godot 4.2 and I have installed an add-on called Shader-Lib. Alright, with all of that out of the way, let's get coding right after the intro. Okay, here I have an empty scene with only Node 3D. Let's create a new shader resource. We are creating a skybox, so select the mode Sky. I will call it Star-Filled Skybox. Now let's also create a material for our shader. Assign our shader to our newly created material. Now the question is, where do we apply our material? Let's click the Sun and Environment Options button thingy. Make sure you have selected Glow and Tone Map Post-Process. Add Environment to the scene. Now we have a World Environment node. In the inspector, expand the Environment resource. In the Sky section, expand the Sky resource. Here we have a Sky material slot. Drag our skybox material and drop it here. And we have successfully applied our skybox material. In our shader, we have this sky processor, which will be called for every visible pixel of our skybox. Let me clear out the comments. Now we are in outer space, so it will be dark, so I'm not changing the background color. Let's keep it pitch black. First, let's just try to draw a single star. For that, let's create a custom method called star, which will return a scalar value, so float star, and it will take UV as an input, so back to UV. For now I will just return 1, so let's create a float variable star equals 1 and return the star. In our sky processor we need to call our star function, so color plus equals star. But the issue is we don't have access to standard UV parameter in the sky processor. We do have sky coordinates, but it's polar coordinates. We don't really need that. So let's calculate our custom UVs using I direction. I direction is just a normalized vector 3 where x, y and z points to the x, y and z axis of our world. Let's just visualize that, so color equals I direction.xxx. We have an x value that goes positive to the right and negative to the left. We have y value that goes positive upwards and negative downwards. And we have z value that goes positive forward and negative backwards. Now we want our star to be parallel to the xz plane. So color.rg equals direction.xz, and it starts to look like our standard UV, which has origin here. Let's use that as UV, so back to UV equals I direction.xz. Then we will pass our UVs in sky function and everything turns white because we are simply returning 1 in our star function. Here let's try to create a star, and for that we can use the length of the UV. And we have this nice gradient effect where the center is black and rest is fading to white. We want the star in the black part. So the first thought can be, let's just invert the colors. Then to make the stars a bit more saturated, we return power of the value, so power of star raised to 3. And power function simply darkens the value which are less than 1 as we increase the power. So if I go raised to 4, raised to 5, it will control the size of our star. But there is a better way to create glowing things. We can divide some smaller number with our length. So let's go 0.01 divided by length. And let's decrease the power a bit, so raise to 3 maybe, to make the glow bigger. And we have a glowing star. I would also like to add the flares on our star. And to make a diamond shaped flares, let's go float rays equals uv.x into uv.y. Let's just visualize that for a second. So star equal rays. We have white parts here and here, which is not a diamond. That's because our x goes negative here and our y goes negative here. So let's do the absolute of the entire thing. And now we want opposite of this, so let's do 1 minus. And we can multiply that with some bigger number, say 1000, to make it look like a flare. Now it can also go to negative. We don't want that, so let's use a max function. Max function will return the maximum between these two, so if this value goes negative, it will simply return 0. Now our flare goes infinitely. So let's multiply the entire thing with star. And we have a nice diamond rays. Let's add that on top of our star, so star plus equals ray. Now we have only single star because our UV goes from -1 to 1. Let's say color dot rg equals UV. We can tile our UV by multiplying some number to it, so like 5. Then only take the fraction part of that, so fract of that. And fract returns only the fraction part or decimal part of the number. And I want to control the number of boxes from the inspector, so let's create a uniform of type float. Uniform float star height equals 5. And let's replace this 5 with star height. Now we have a grid with bunch of boxes that I can adjust from the inspector. But the origin of each box is in the corner. I want the origin at the center, so simply subtract 0.5. Actually, let's just take the fraction part out and just create a new variable. Back to grid UV equals fraction of UV and subtract 0.5. Let's visualize grid UV instead. And we have boxes with the origin at the center. But notice that our grid is kind of stretching at the horizon. And the reason is our skybox is essentially a sphere and our grid is trying to wrap around it. In order to make it parallel to xz plane, we need to divide I direction.xz with I direction.y. Now our grid is parallel to the xz plane. Okay, let's pass grid UV instead in our star function. And we don't need to visualize the grid anymore. Now we have a bunch of stars, but at the horizon it looks really bad. Let's try to fix it. So I direction.y goes from -1 to 1. We want positive values, so we will take the absolute of that. So float blend equals absolute of I direction dot y, and let's just visualize that. So color equals vec3 of blend. We have this gradient which is black at the horizon. We can control this blend with smooth step function, and I want to control the blend from the inspector, so let's create another uniform float star blend, and I want the value to only go from 0 to 1, so let's use hint range. So hint range 0, 1 and 0.01 equals 0.1. So our star blend will go from 0 to 1, and the slider step will be this big. Then let's go smooth step star blend 1 and absolute of I direction. And what smooth step does is, if this value is less than this value, it will return 0. If it is greater than this value, it will return 1, and if the value is between these two, it will interpolate that between 0 and 1. Alright, we can control this blend from the inspector. We will multiply our blend with our stars, so blend, and we don't need this anymore. And now our horizon doesn't look too clustered. Pretty cool. Now if I decrease the star height a bit, our stars kind of look like a flat plane. There's no sense of depth in it. I don't really like that, so let's create another variable, float depth curve equals power of absolute I direction dot y, and I want to control the power from the inspector, so let's create another uniform. Let me duplicate the star blend and call it depth blend and pass it in our power function. Then we will divide our I direction dot xz with depth curve instead. Let me reset the star height so we can see what's going on. So the depth curve will make it so that if our depth blend is 1, our stars will be flat, but if we decrease the value, it will try to wrap around the top part, and the stars that are near the horizon will be flat, just like that. Now all our stars are the same size. Let's try to randomize that. We can control the star size by multiplying some values with our stars. Let's also make this uniform so we can control it from the inspector. Uniform float star size equals 5. Then replace this with our star size, and we can control the size from the inspector. But that will be the same for each stars. I want to randomize that. So let's firstly create a function that will return a random vector. So vec2 random vec2, and it will take vec2 as an input. Let's say seed. Let's go seed equals seed into some vec2 123.45 784.29. Then let's take the fraction part of that, so fract of that, then seed plus equals dot of seed and some random vector, let's say 875 dot 34. Then let's do float x equals fract of c.x into try 164.32 and float y equals fract of c.y into 287.21. And this is just maths trickery to get a pseudo-random number. I'm just taking the vector and multiplying it with some big vector and taking the fraction part of that. Then I'm adding a dot product of our vector with some random vector. Then for x, I'm again multiplying the x value of our vector with some numbers and taking the fraction part of that, so it will be between 0 and 1. Same thing for the y. We can stick any values here, just make sure that they are not multiples of each other. Then let's return new vector 2 of xy, so return vector 2. And our vector will be between 0 and 1. I want that to be from minus 0.5 to 0.5, so we go minus 0.5. This will be between minus 0.5 to 0.5. Okay, now we have a function that takes vec2 as an input and return random vector. Now in our Sky processor, for every boxes we want to get a random vector 2, but to get that we need an ID for each box. And we can get that by simply using the floor function, so vec2 grid ID equals floor of UV. Floor just takes the integer part of the number, or let's say the number before the floating point. Let's just visualize our grid, so color.rg equals grid ID, and we cannot see it because the colors are very saturated. Let's desaturate them by dividing the grid ID with some bigger values. Now we can see that the grid ID is different for each box. Of course these are black because the number there are negative. Now based on the grid ID, we can get a random vector using our custom function, so vec2rv for random vector equals random vec2 and pass grid ID. Then for the random star size, let's go float size equals rv.x. This will be the random value between minus 0.5 and 0.5. I want it to go from 0 to 1, so rv.x plus 0.5. Then we will multiply the entire thing with our star size, so then use size instead, and we have stars with different size. Now I don't want the flares to be on every stars. I want a way to control the flare, so let's just add a parameter in our star function, float flare, and multiply our rays with the flare. So here if we pass 0, we have stars with no flare, and if we pass 1, we have flares on every stars. And to control that, let's create one more uniform. Let me just duplicate the depth blend. I will call it flare ratio. Then here let's just use smooth step, so float flare equals smooth step star size into 1 minus flare ratio, then star size and size, and let me pass the flare here. So this will make it so that if I set the flare ratio to 0, none of the stars will have flares. If I set it to 0.1, only 10% of the stars will have the flares. And if I set it to 1, every star will have the flares. Awesome! Okay, now our stars are at the center of each grid box. They are looking too uniform, so let's just offset them a bit. We can move our stars by subtracting a vector from our grid UV. But we want to move each star randomly, and we already have a random vector RV, so let's go RV. And now we can see that some of our stars get too close to the edges of our grid box that it gets cut out. Let me draw a grid to better see it. And you can see that this star gets cut, this one as well, also this one. So we need to add the color of all the edges in grid boxes and add it to the center grid box. We can do that by creating loops. So for float y equals -1, y less than equals 1, y plus plus, then one more for float x equals -1, x less than equals 1, x plus plus, and put all of this inside the loop. Now we are essentially doing same thing 9 times, which is not what we are after. We want to iterate over adjacent boxes, so let's create a variable vec2 offset equals vec2 of x and y. Then we will add this offset on top of our grid ID as well for random vectors, so offset. And in the star function, let's subtract offset as well from the grid UV. So basically what we are doing is, let's say we are in this box, we are calculating all the color data of all the adjacent boxes, and if the color bleeds to our current grid box, we are adding that to this box as well, and our stars no longer gets cut at the edges of the boxes. Nice. And we don't need the grid anymore, so now let's add colors to our stars as well. Again, we want different colors for our stars, so we will use a hue function to shift the hue of our color. Hue function is from the add-on Shader-Lib, so first we need to include that shader include file. Let's go on top of our shader, and let's say here hash include. Then we want to pass the path of the shader include file, and the default path will be add-on Shader-Lib artistic adjustment UGD shader include. And this line means we have linked this file to our current shader, and now we can use hue function. Back in our Sky processor, let's go vec3 star color equals red color, so vec3 of 100, and if we multiply our color with our star function, all of our stars will be red. Now let's shift the color hue for each star, and for that let's use hue function, so hue of red. Now this offset is the hue offset. Let's pass our rv.y, and for the range index let's pass 1. The possible value for this is 0 and 1. If we pass 0, this offset can go from minus 360 to 360, and if we pass 1, the offset can go from minus 1 to 1. Now this rv.y can only go from minus 0.5 to 0.5, and I want it to go from minus 1 to 1, so simply multiply it with 2. And now we have colorful stars. However, I don't really like confetti colored stars. Let's try to filter the color a bit. Star color multiply equals vec3 of 111. So this is the original color, and let's try to filter out green color a bit. So 0.2 in G channel, and I want bigger stars to be more bluish. So in Z component, let's say 1 multiply size, and it looks nice. Anyway, this is the stuff you can play around with to your heart's content. Okay, this looks nice. Let's try to add a bit of twinkle to our stars as well. For that, let's go float animated size equals sine of time into rv.x, and this will go from minus 1 to 1. I want it to go from 0 to 1, so simply multiply it with 0.5 and add 0.5, and then multiply the entire thing with star size. So multiply size, so this will go from 0 to whatever size we have. Then let's multiply our star function with animated size instead. And now our stars are twinkling, but it's too slow, so we can multiply some bigger number here to make it faster. 20. Now our stars are twinkling, pretty amazing. But our stars go completely black because this thing can go from 0 to 1. I don't really want that, so let's make it so that it only goes from 0.2 to 1. So 0.4 and 0.6. Now our stars don't go completely black, which is amazing. But I want to control the twinkle speed from the inspector, so let's make a uniform float twinkle speed, and then multiply that instead. And now we have a bunch of twinkling stars. However, this is only one layer. We can add a bunch of them, so let's just do that. But first I will cut out this thing in its own function. Which returns a color, so vec3 star layer, and it takes UV as an input, so vec2 UV. Now obviously we need to return the color, so let's go vec3 stars equals vec3 of 0. Then instead of color, let's use stars. Now we have an unknown variable blend here, so let's just remove it and then just return stars. In our sky processor, let's call our star layer, so color equals star layer and pass UV. Then we need to multiply that with blend to cut out star cluster from the horizon. Now let's add some more star layers, and I want to control that from the inspector. So let's create another uniform int this time. Uniform int star layers equals 3. Then let's write a for loop here. For float I equals 1, I less than equals star layers, and star layers are integer, we need to convert that to float, and I plus plus, and add this to line in our loop, and we need plus equals here. Now obviously the layers are drawn on top of each other. Let's try to change the star height for each iteration, so simply multiply I. But now if we increase the layers enough, then the layers are uniformly stacked one over another, and I don't want that. So let's add something to our UV to make it different for all layers. So UV plus equals random vec2, let's make vec2 of I, and I plus some random number 34, then multiply that with I, and also multiply it with another random number 4.4, and we have randomized star layers. Finally, if we look closely, our bottom part of skybox is just the reflection of top part. And I don't like that, so let's just rotate the bottom part in some arbitrary angle. For that I will use rotate UV function from the add-on, so let me first include it. Now we can distinguish between top and bottom part using I direction.y. For top part it will be positive and negative for the bottom part, so let's go if I direction.y is less than 0. Let's rotate the UV, so UV equals rotate UV, rotate this UV, and the center will be 0, 0. Then let's rotate it, I don't know, 170 degrees, and we are using degrees, so pass true in use degrees parameter, and boom, now our bottom part is no longer the mere reflection of top part. That's it for our shader. We can adjust our parameters to customize the look. And that's pretty much the video. I will end by repeating the same words that I've said on the very first Godot shader video. Try to learn the shading language. I know visual shaders are easy. I can understand that programming is hard. But once we learn how to code, we can stretch our legs a bit more to create a more complex shader or effect. Take this one for the example. I mean, we have written some 60 lines of code here, but the same effect is hard to recreate using just visual shaders. Having said that, I want to clarify that I will still continue to create visual shader tutorials. No need to worry. And that's enough TED Talk for one video. If you find the video helpful, hit the like button, share it with your friends, subscribe for more videos like this. If you have any questions, post them in the comments. Wishlist Cosmic Roads on Steam. That's it from me, and I will see you guys in the next one.